Question 6 then is a binomial expansion question. So we're given this binomial here, and we're told the coefficient of the x squared term is 135n, where n is an element of the positive integers, and we're asked therefore to find n. So given that the coefficient of the x squared term is what we've been provided with, let's have a look at the expansion. So we've got n here, so we're going to have n choose 2, 3x squared multiplied by 1 to the power n minus 2. I know that this is 2 because that's squaring this is the only way I can get the x squared term. If this is 2, then I'm going to make this 2, and these two together have to add up to n, so this must be n minus 2. So I know that this is going to be giving me the x squared term, and that therefore will be 135n multiplied by x squared. So the coefficient here will obviously be what I'm left with on this side. So n choose 2 is going to be n factorial over 2 factorial multiplied by n minus 2 factorial. The expansion of this is going to give me, again, using our laws of indices, this is the same as 3 squared times x squared, or just 9x squared is the same as 135n x squared. Now I can cancel out the x squareds here, and then I need to look at more detail at this expression over here to simplify it. So n factorial is the same as n multiplied by the number before it, multiplied by the number before that, etc., etc. And I'm going to divide that by 2 factorial, which is just 2 times 1, multiplied by n minus 2 factorial, which is n minus 2, multiplied by the number before it, n minus 3, etc., etc. And you can see that I can cancel out these. So I'm left with n multiplied by n minus 1 over 2 multiplied by 9 equals 135n. So if I just look at the numerators here, I'm going to have n squared minus n multiplied by 9 is going to equal, and then I'm just going to take this 2 and multiply up here, so I end up here with 270n. So you can see that if I multiply and tidy up, I'll end up with 9n squared minus 9n minus 270. n equals 0, so that's 9n squared minus 279. n equals 0. And from here I can factorize. So if I take out 9n, I will be left with n minus 31 equals 0. So therefore either this can equal 0, in which case n equals 0, or this can equal 0, in which case n is equal to 31. However, back in the question, we are told that n is an element of the positive integers, and therefore we can discount this and say that n equals 31.